Hi, how's it going? Welcome to Code with Z. In today's video, we have to find out with how many coins we can reach the number 6. Why? Well, because that's what LeetCode 322 coin change is asking us to do. As you can see, it says you're given an integer array called coins. So for example, this array that we have here representing coins of different dimensions, and an integer called amount. So for example, this 6 that we have here representing a total amount of money. So for example, we can basically treat these numbers as money. So this is a $1 coin, this is a $2 coin, this is a $5 coin, and our amount that was given to us is $6. Now let's see what we're being asked. Here it says, return the fewest number of coins that you need to make up that amount. Meaning, for example, if we have $6 and we're given only these coins, we need to find out what's the minimum number of coins we can have to reach $6. So for example, to reach $6, we can have 6 $1 coins, or we could have 3 $2 coins, or we could have 1 $5 coin and a $1 coin. You get the idea. And then it says if the amount of money cannot be made up by any combination of the coins, return -1. And then at the end it says you may assume that you have an infinite number of each kind of coin. So for example, we can have 6 repetitions of the $1 coin. We can use them as many times as we want. All right, let's see how you can solve this. So again, these numbers inside of the array are our coins, and this is our amount that we need to figure out with how many coins we can reach it. All right, let's see how you can solve this. So our approach is gonna be really simple. I'm gonna visualize everything. The approach that we're gonna use is gonna be dynamic programming, and I'm a fan of explaining and showing instead of just explaining. So I'm going to explain it and then I'm going to show you everything, and we're going to visualize the whole algorithm. So when we use dynamic programming, we have to break down the problem into really smaller problems. And the way we're going to do this with this problem is that we're asked to find out how many coins we need to reach 6. Well, we could basically say, how many coins do we need to reach $0? How many coins do we need to reach $1? How many coins do we need to reach $2? That's going to be our approach. So we're going to break it down into smaller problems, and then we're going to use those to reach 6. So let's start. We're going to have a variable called dp, and this is going to be an array that's going to be representing how many coins we need to reach each number. When we start, we don't know how many coins we need, so we're just going to fill it with a bunch of infinities. Now you might be like, what's this array? Why does it have this length and all of that? Well, let me show you. This array represents how many coins we need to reach each number, as I mentioned. So for example, this first position here is representing how many coins we need to reach $0. This one represents how many coins we need to reach $1. This one represents how many coins we need to reach $2, 3, 4, 5, 6. As you can see, the length of this array is 7 because our arrays are 0 indexed. So we basically start from 0 all the way till the number that we were given. As you can see, we were given 6, and here we have 6. So this array at the end of our algorithm is going to contain how many minimum coins we need to reach, for example, $3, to reach $4, to reach 5, and then at the end to reach 6. Awesome. Now that we know this, can you guys tell me how many coins we need to reach $0? Well, 0, right? To reach $0, we need 0 coins. All right. So we know when we start, the first element inside of our array is going to have the value of 0. All right. Awesome. We found one of the answers. So we only have 6 more to go. All right, let's see how you can find the other ones. So the approach is going to be really simple. I'm going to visualize it and explain it as we go because I think it's going to be better than just explaining it through words. I want you to see it. So we're going to loop through our array because we need to update these values accordingly, right? We have these coins and we need to update these values. All right, so we're going to loop. And because we need a loop, we're going to have a variable, for example, called I, and this is going to be the variable for our for loop because we're going to have a for loop. And this I is going to start with the index of 1. Why? Well, because we've already taken care of the first element inside of our array. So we don't need to start from 0. We already know that the first element has to have the value of 0. We have already discussed this. To reach $0, we need 0 coins. All right. So we need to figure the rest of these out, right? So we're going to start with 1. And then we're going to start looping. So we're going to start looping, and 1 is basically pointing to this position because this position has the index of 1 inside of our DP array. And we're going to do the following. We're going to be like, okay, we want to fill out this position, and these are our coins. Let's explore them one by one. What if we have 1? What if we only consider the coin that has the value of $1? Well, let's see. This position wants to find out how many coins we need to reach the value of $1. Well, let's see. We need to find the minimum amount of coins, right? So we're going to have a minimum value. I'm going to explain this. We're going to say dp at the index of I, basically what we have here. So dp at the index of I is dp at the index of 1, or this infinity that we have here. So we want to find the minimum between infinity, or the current value that we have, and the value that we're trying to come up with using the coin that we have. We're going to say dp, which is our array, at the index of I, which is 1, minus the value of the coin, which is 1. 1 minus 1, that's going to give us 0. dp at the index of 0 is going to be 0, like so. We're getting that value, the previous values we had, and now we're adding 1 to it. Why 1? Well, this 1 is representing our new coin. We want to find out how many coins we need to reach each value. Each time we add a coin and we consider a coin, we need to increment the value, right? For reaching $0, we needed 0 coins. Now we're trying to find out how many coins we need to reach $1, right? So we're getting the previous calculation, which was 0, and then we're going to add 1 to it because we're considering what will happen if we have the coin with the value of $1. And since we're using a coin, we need to increment the number of coins we have because these are representing the number of coins that we have to reach each value. So 0 plus 1, that's going to give us 1. The minimum between infinity and 1 is going to be 1. So we're going to update this to be 1. And then we need to consider the other coins. Let's see if there's a possible way to reach the target value that we have here, which is $1, because again, this array tells us how many coins we need to reach $0, $1, $2, $3, $4, $5, $6. Because we're here currently, we're trying to find out the minimum amount of coins we need to reach $1. So we need to consider all of the possible scenarios. So we're going to move on to the next coin. But when we check, the next coin starts with 2. And there's no possible way to reach 1 when the minimum value is 2, right? So we're not going to consider it because we want to reach 1, but this coin has the value of $2 and we want to have $1. And there's no possible way to use a $2 coin to reach a $1 goal. So we're gonna ignore it. And same thing for 5. We have a $5 coin, but we wanna reach a $1 goal. So we're gonna ignore it as well. And then we're gonna increment I because this is a loop. And then we're gonna move on to the next position. In this position, we're trying to find out how many coins we need to reach $2. All right, let's explore our coins. We're gonna start with the $1 coin. We're gonna be like, okay, let's figure this out. We're gonna say, again, same thing. We're gonna say minimum between dp at the index of I, which is basically our infinity, because dp at the index of I, which is 2, that's gonna give us our infinity. And then we're gonna say dp at the index of I minus coin, meaning the coin value plus 1, because we're adding a new coin. I is 2, coin is 1, the value of our coin is 1, 2 minus 1, that's going to give us 1. dp at the index of 1 is going to be this position that has the value of 1, 1 plus 1, that's going to give us 2. The minimum value between infinity and 2 is going to be 2. Now you might be like, what's this representing? Well, let's think about it. This is representing how many coins we need to reach $2, right? Currently, we're exploring the possibility of only using the $1 coin. And then we're saying, okay, if we want to reach $2 and we only have a $1 coin, we need 2 coins, right? It makes sense. But then we can also check the $2 coin. This time we can actually explore this possibility as well because we want to reach $2 and we can actually consider the $2 coin because it's not bigger than our goal. Here we're going to again have our formula. This time dp at the index of I is 2 because we updated it and it became 2 and it's not infinity anymore. And then we're going to say dp at the index of I minus the coin value, I is 2, minus the coin value, which is 2. 2 minus 2, that's going to give us 0. dp at the index of 0 is 0. 0 plus 1 is 1. The minimum value between 2 and 1 is going to be 1. So we're going to update this. And it makes sense. If we want to reach $2 value, we can just use one $2 coin. It just makes sense, right? And then we want to explore the $5 coin, but the $5 coin is already bigger than our $2 goal for this position. So we're going to ignore it and we're going to move on to the next round. In this round, I is going to get incremented because it's a for loop. And then we're going to be exploring how many coins we need to reach $3. All right, let's explore our coins. The first coin that we're going to explore is going to be the $1 coin. We're going to have our formula again. We're going to say the minimum value between dp at the index of I, which is dp at the index of 3. That's going to give us infinity because it's going to be this position. And the other value is going to be dp at the index of I minus coin. I is 3, coin is 1, 3 minus 1, that's going to give us 2. dp at the index of 2 is going to be this position. So it's going to give us 1, 1 plus 1, because we're adding a new coin. That's going to be 2. The minimum value between infinity and 2 is going to be 2. Simple as that. And then we're going to explore the next coin. We're going to be like, we want to reach $3. Can we use the $2 coin? Well, yeah, our goal is bigger than our coin. So we're going to be like, okay, min dp at the index of I, which is 3. dp at the index of 3 is going to be 2 because we just updated it. And then dp at the index of I minus coin. I is 3 minus 2. That's going to give us 1. dp at the index of 1 is going to be this position that we have here. That's going to be 1. 1 plus 1, that's going to give us 2. The minimum value is going to stay as 2. And it makes sense because if we want to reach $3, we need a $1 coin and a $2 coin minimum. Now we want to explore the 5, but the $5 coin is bigger than our $3 goal. So we're going to ignore it and we're going to move on to the next round. I is going to get incremented. And now we're exploring how many coins we need to reach $4. Again, same thing. We're going to start with 1. This is going to be our $1 coin. We're going to have our formula. The minimum between dp at the index of I, which is going to be dp at the index of 4. That's going to be our infinity here. And then dp at the index of I minus coin. I is 4. Coin is 1. That's going to give us dp at the position of 3. That's going to be 2 over here. 2 plus 1, that's going to give us 3. The minimum between infinity and 3 is going to be 3. So let's update this and then we're going to explore the next coin as well because the current coin is smaller than our goal, which is $4. All right, let's check it again. Minimum between dp at the index of I, which is going to be dp at the index of 4 because I is 4. That's going to give us 3. And then dp at the index of I minus coin, 4 minus 2. So 4 minus 2, that's going to give us dp at the index of 2. dp at the index of 2 is going to be this one that we have here. So 1 plus 1, that's going to give us 2. The minimum between 3 and 2 is going to be 2. And it makes sense because if we want to reach $4, we can simply use 2 occurrences of the $2 coin. All right, let's explore 5. We can't because 5 is bigger than our $4 goal. So we're going to move on to the next round. I is going to get incremented. And now we're exploring the value of $5. We want to see how many coins we need to reach $5. Again, we're going to start with the $1 coin. We're going to say minimum between dp at the index of I, dp I minus coin. dp at the index of I is going to be dp at the position of 5, and that's going to be infinity. And then dp at the index of I minus coin, 5 minus 1, that's going to give us 4. dp at the position of 4 is going to be 0, 1, 2, 3, 4. This position, all right, let's get it. 2 plus 1, that's going to give us 3. And then the minimum between infinity and 3 is 3. Now let's explore the other possibility with our $2 coin. We're going to say we want to find the minimum again between these two values. dp at the position of I, dp at the position of 5 is going to be 3. And then this position here, dp at the index of I minus coin, I is 5, minus coin value is 2, 5 minus 2, that's going to give us 3. dp at the index of 3 is going to be 0, 1, 2, 3. So it's going to give us 2. 2 plus 1, that's going to give us 3. The minimum between 3 and 3 is going to stay as 3. But when we want to explore our $5 coin, we can actually use it. Why? Well, because now we're exploring the possibility of how many coins we need to reach $5. And we can easily use our $5 coin because $5 is not greater than $5. They are equal. All right, we're going to say min dp at the position of I, meaning 5, that's going to give us 3. And then dp at the position of I minus coin, I is 5, minus coin is 5. 5 minus 5 is going to give us 0. dp at the position of 0 is 0. 0 plus 1 because we're adding a coin here, and that's going to be our $5 coin. That's going to give us 1. The minimum between 3 and 1 is going to be 1, so we're going to update this. And it makes sense. To reach $5, we can simply use a $5 coin. Now we're going to move on to the next round. Our I is going to get incremented, and now it's going to be equal to 6. And we're exploring the possibility of reaching $6. How many coins we need to reach $6? And that's the requirement of the question. So let's see, we're going to have the same thing. We're going to first explore the $1 coin, minimum between dp at the index of I, dp at the index of 6. That's going to be this value that we have here. And then dp at the index of I minus coin, I is 6, coin is 1, 6 minus 1, that's going to give us 5. dp at the position of 5 is going to be 1, 1 plus 1, that's going to give us 2. The minimum between infinity and 2 is 2. But now we're going to explore the $2 coin. We're going to be like, let's again have our formula. The minimum between these two, dp at the position of 6, that's going to give us 2. And then dp at the position of I minus coin. I is 6, coin is 2. That's going to give us 6 minus 2. That's going to be 4. dp at the position of 4 is going to be 0, 1, 2, 3, 4. So 2, 2 plus 1, that's going to be 3. The minimum between 2 and 3 is going to be 2. So it's going to stay as 2, and we're going to move on to the next coin, which is going to be our $5 coin. And we can use it because we're trying to find out how many coins we need to reach $6, and $5 is smaller than 6, which is our goal. So we're going to use it. Again, we're going to say minimum between dp at the index of I, which is 6, and that's going to give us 2, and dp at the index of I minus coin. I is 6, coin is 5, 6 minus 5, that's going to give us 1. The position of 1 has the value of 1, and that's going to give us 1 plus 1. 1 plus 1 is going to be 2. The minimum between 2 and 2 is going to stay as 2. And it makes sense. To reach $6, we need a $5 coin and one $1 coin. And that's why we have 2 here. We're going to be done with our loop, and then at the end, we're going to return the last element inside of our array, because this is what is representing how many coins we need to reach $6, just like we saw. So we're going to return this at the end, because again, we need a $1 coin and a $5 coin to reach $6. Now, let's code this in the simplest way possible. Alrighty, let's code this together. So just like we saw in the slides, we're going to need our dp array, and this is going to be a new array, and it's going to have the length of amount plus 1. Why? Well, because we need to also consider the case where we have $0 and we need 0 coins, right? And we want to fill it with infinity in the beginning. And then we need to update the first value inside of our array, and that's going to be equal to 0, just like we saw in the slides. And then we're going to have our simple loop. We're going to say for let I being equal to 1, just like we saw in the slides. We want to start with 1 because we've already taken care of the first value that has the index of 0. So we're going to start with 1, and we want to keep on looping as long as I is smaller or equal to amount. That's basically the $6 or the value that we need to reach with our coins. And then we want to have I++ incrementing I on each round, just like a normal for loop. And then here we need to go through our coins. So we're going to say for let coin of coins, and then we need to explore the coin if it is not bigger than the value that we want to find. So for example, if we want to find out how many coins we need to reach $3, we can consider coins that are greater than 3. So we're going to say if I minus coin is greater or equal to 0, do the following. Basically, consider it. I is going to be also representing the number of the current position. So for example, if we want to explore how many coins we need to reach $3, then 4, then 5, I is going to help us with that, because I is going to get incremented with that, and we can use the I value to do this calculation that we have here to make sure that our coin that we're exploring is not bigger than the amount for that position. Here we're going to say dp at the position of I is going to be equal to math.min, basically what we saw in these slides, between dp at the position of I and dp at the position of I minus coin and plus 1, because we're adding a new coin. And that's going to be it. At the end, we need to return the last element inside of our array. We could basically say return dp at the position of amount. So for example, the 6th position if we have $6, or the 7th position if we have $7, whatever the amount is. This is basically the last element. We can also say dp.length minus 1, the last element, but this is cleaner. But what if we can't reach the value? So for example, if the amount that we're given is 3 and we only have a $2 coin, we can never reach 3 with a $2 coin, right? So we need to return minus 1 if that's the case. And we can figure this out because if we can't reach the answer, the last element inside of our dp is going to stay as infinity. So we can easily say if the last element inside of our array is equal to infinity, if that's the case, this is like an if statement. So if that's the case, we want to return minus 1. Else, if that's not the case, we want to return the last element inside of our array. If the last element is equal to infinity, minus 1. If that's not the case, meaning else, return the last element because it's going to contain the answer. Now let's run this and see if we can actually get accepted. And we got accepted. Awesome. Now let's submit this and see if we can actually pass all of the test cases. And yep, we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.